Today's lesson is on changing dimensions. And what we're going to find out is that if we have a solid and we multiply the dimensions or the linear measurements by a scale factor of A, then the surface area is going to be A squared times the original surface area, and the volume will be, you guessed it, A cubed times the original volume. So this kind of comes from our previous lesson when we talked about similar solids, and we found that the ratio, if we know the scale factor of two similar solids, then we know the scale factor, the ratio of the surface areas was A squared to B squared, and the ratio of the volumes was the cube of whatever the scale factor ratio is. So let's come here and look at some examples. The surface area of a figure is 736 square inches. If the dimensions are multiplied by 1/4, so clearly I'm going to have a smaller volume, what will be surface area, what will be the surface area of the new figure? So if I'm multiplying my dimensions by 1/4, I have to square that. Because I look right here, I have to square that to find the surface area of the new figure. So that's 1/16. So I take the surface area of my original figure, multiply that by 1/16, and that gives me a surface area of 46 square inches. So the original surface area, 736. If I have a solid whose dimensions are 1/4 those of the first one, then its surface area will be 46 inches squared. Okay, got a couple of cones here. Cone A and cone B are similar. If cone A has a surface area of 1,422 and cone B has a surface area of 158, how many times larger is cone A than cone B? So let's see what we got here. The surface area of cone A to the surface area of cone B is 1422 to 158. All right, so if I need to know what this, let me simplify this here. That's going to give me 9 to 1. Right, 158 goes into 1422 9 times. All right, and then if I want to know what the scale factor is, then I'm going to have to do this. Sorry, S2. I'm going to take the square root of 9, divide it by the square root of 1, and that's going to give me 3 to 1. So that's going to tell me that cone A is 3 times larger. All right, so I had the surface area, so I had to take the square roots of those to find the scale factor. How about number 3? The volume of a figure is 972 cubic meters. If the dimensions are doubled, what will be the volume of the new figure? So I've got volume. If I double the dimensions, what do I have to do? Let's go back to the top. You see, if I multiply the dimensions of a solid by a scale factor of A, then the volume is going to be A cubed times that. So if dimensions are doubled, then I got to cube that to get the volume. So 2 cubed is 8. So therefore, I know that the new figure is going to have a volume of 972 times 8. So that's going to be 7, and that's going to be 5. 7,076 cubic meters. Okay, I think, one more. Here we go. Solid A is similar to solid B. If the volume of solid A is 21 cubic inches and the volume of solid B is 4,536, how many times smaller is A than B? Okay, let's set up a ratio here. I got the volume of A and the volume of solid B, and I know that that is 21 to 4,536. Okay, so if I were to simplify this, 21 will actually go into 4,536 216 times. So this simplifies to 216. So those are volumes. What I want to do now is find the scale factor. So the scale factor of A to the scale factor of B is going to be the cube root. The cube root of 216. So that is going to be, the cube root of 216 happens to be 6. So therefore, how many times smaller is solid A than solid B? 6 times smaller. So really all I'm doing is going back and forth with the ratios of scale factors, surface areas, and volumes. Okay, what are the effects if I change only one dimension? Well, if I have a solid and I change only one of its linear measurements, I don't have similar solids anymore, do I? So I need to approach this in a different way. So if I change only one dimension, I have figures that are not similar, which means we got to use a different strategy. In this situation, why don't we just choose some test values? And when we choose test values, we're not going to choose 1 or 2. Hopefully you could figure out why you wouldn't want to choose 1 or 2. Raising 1 to any power isn't going to change it. We don't want to use 2 because 2 squared is the same as 2 times 2. So we're going to choose other numbers besides 1 or 2. And then we'll compare our answers and see what we get. So let's do a few examples. How many times larger is the volume of a cylinder if the height is doubled? Okay, well let's take cylinder 1. So the volume of cylinder 1 is pi r squared h, right? The area of the base times the height. So why don't we here come our test values. We're going to let r equal 3 and we're going to let h equal 5. These are just the values we're using. So volume of this first cylinder is pi times 9 times 5, which is 45 pi. Okay, and so for our other cylinder, cylinder 2, we got the same formula for volume, pi r squared h. And this time the height is doubled, so r is going to remain 3, but h is now going to be 10 because we're doubling the height. So this cylinder is going to have a volume of pi times 9 times 10, which is going to be 90 pi. So we can see that the volume of this second cylinder is twice that of the original. How many times larger? It's twice as large. Alrighty, so there are several examples here. I'll do at least a couple more of them, but we're going to approach all of them in pretty much the same way. So how about I do number 2, then you stop the video, you try to do the other 3, and I'll put the answers up here for you. Number 2 says, how many times larger is the volume of a square pyramid if the base edge is tripled? Okay, so we're dealing with volume again, so let's take volume 1. This time we got a square pyramid, so if we're finding the volume of a pyramid, that's 1/3 the area of the base times the height. So I know the area of the base this time, we got a square, so that's going to be s squared. So let me just substitute that in here. 1/3 s squared times h. All right, and again, I'm just going to go ahead and pick 3 for my side length, 5 for my height. So the volume will be 1/3 times 9 times 5, which is going to be 15. And it's okay if I don't put my units at this point. In the end, the units will be the same, and I'm looking to see how much larger one is than the other. If your final answer has units, of course you have to put the units. All right, so let's look at the volume of this second pyramid. So once again, 1/3, and it's still a square pyramid, so I'm going to say the area of my base is s squared. All right, and what am I doing here? I'm letting the base edge be tripled. So that means my side length instead of being 3 is now going to be 9, and my height is still going to be 5. So let's plug that in here. We have 1/3 times 81 times 5. Let's see, 3 goes into 81 27 times. So the volume of this second pyramid will be 27 times 5. So that's 5 and 3, 135 if I'm not mistaken. And how many times will 15 go into 135? 4. That's 4 times. So how many times larger is the volume of the square pyramid if I triple the edge length? 4 times larger. Okay. 3 more problems here. Again, please pause the video now, work these, and then come back and check them. All right, so here are the solutions for you. You see, I do want to point out what I did here in these problems. You know, before on the previous page, I let r equal 3 and h equal 5. And that's fine, but you see when my problem tells me that I'm going to multiply the radius by 1/2, I'm going to half the radius. Well, it just makes sense to me that I want to pick an easy number, a nice even number that's divisible by 2, so I don't have to deal with fractions, because I know we don't really care that much for fractions. So that's the only reason I picked 6. I could have picked any even number, but I picked 6, and so therefore when I half the radius, I do get 3, and then when I work out my calculations, I see that I will have a sphere that has a surface area that's 4 times smaller. All right, in number 4, I was going to make the side length of this new cube 1/4 as long. So once again, when I picked my side length, I wanted something that was divisible by 4, so I didn't have to have a fraction. And so there we go. That answer there is 16 times smaller. All right, so hopefully you did these and you're checking your answers. And then finally in number 5, if I'm going to take this cone and I'm going to multiply its radius by 6, then once again I went back to my old standbys. Let the radius be r, the height be 5, and then when I multiply that radius by 6, I get then a radius that is 18, whatever the units are, and when I plug those into my formula, I find out that this second cone will be 36 times larger. The volume will be 36 times that of the original cone. All right, so write yourself a summary. It's not on this page, it's actually on the next page, but go ahead, write yourself a summary, and we'll see you next time.